I don't think it'll be a hotel. Oh, we're recording. Right. So the homework this week was vectors and some other stuff. So we start with the points A, B and C, have position vectors there, where P is a constant. Given that the angle ABC is 90 degrees, find the value of P. So we've got that. OA vector -5, -10, 12. Let's just think about what information we've got here. OB is 1, 2, -3, and OC is 3, 6P. The angle ABC is 90, find the value of P. So if you think about what we've got, diagrams often help. We've got 3 points, A, B, and C, and we've been given those vectors. And what we're told is that the angle between AB and BC is 90 degrees. That's what that means. So that angle there would be 90 degrees. So what we need to do is to find the vectors that are departing point B so that we can do our dot product. So we need to know the 2 vectors that are marked in red there. Does that make sense? So the first job is to find those vectors. The vector BA, thanks, would be minus that one plus that one. Does that make sense? Because we're going to go back to the origin and then we've got to A to do the same as BA. So that is -6, -12, 15. So that's the vector BA. Well, it will probably work out, because it's the direction that matters. Although you may get something odd going on with the direction. We'll see how it all ends up. BC is the negative of 1, 2, -3. Quite warm in here. Plus 3, 6P, which gives us 2, 4, 3 plus P. Now, these 2 vectors that we've got here, they are perpendicular to each other. That means the dot product of the 2 vectors that are departed at 90 degrees come to what value? 0, because the cos of 90 is 0. So that means that -6, -12, 15, dotted with 2, 4, 3 plus P is equal to 0. So if we work that through, that's -12, take away 48, plus 15 lots of 3 plus P is 0. Aha, we've got 15 times 3 plus P equals 60. So 3 plus P is 4. So P is 1. You get P is 1.
No. But I wrote down 1 for the 3 as 1.
Does it matter if you do A, B?
Where do you get the marks?
It shouldn't matter, no. Because all that you're doing there with AB is you're taking that vector, or the equivalent of that vector, just have it in the opposite direction. And of course, if it's 90 in that direction, it was also 90 in that direction.
I've got P equals -5.8.
Right, it's not. Part 2. Given that instead ABC is a straight line, find the value of P. Well, all that means is if ABC is a straight line, that means that, in effect, the 2 vectors that we found have to be in opposite directions, don't they? Or they have to at least be in the same sense. So their dot product, this time, well, we could do it with the dot product, or we could just do it, the easiest thing to do is probably that these would have to be parallel vectors now, wouldn't they? So if they're in the same direction, then one must be a multiple of the other, because they're exactly the same direction, they're parallel. So what we're saying is that -6, -12, 15, part 2, is equal to some constant times the other one, which is 2, 4, 3 plus p. Okay? And just comparing that, we've got that, if you look at the I bit, k is negative 3. That also works for the j direction, and if we look at the k part of this, we've got 15 is minus 3 times 3 plus p, which gives us 15 is minus 9 minus 3p, or 3p is
minus 28.
Minus, yeah. So p is negative 8.
Maths.
Yeah, it's a bit of maths now. That's tricky. Good. Excellent. We've done very well. 6 marks. We then threw another vectors question in for you, which I think this was a question 1 on a past paper. Find the angle between those two vectors. Well, remember we wrote down that this was our definition of the dot product and the scalar product. It was like that. And if we rearrange that, we get that the cosine of the angle between these vectors is the dot product divided by the product of their magnitudes. So that's what we've got to work through for this. We've got to do the dot product of 1 minus 2, 3 and 2, 1, 1 divided by the product of their magnitudes. Which gives us, on the top line, we've got 1 times 2 minus 2 times 1 plus 1 times 3. And on the bottom line, we've got root 14, root 6. And so, altogether, we have 1 over root, whatever that is, 84.
Are you sure it's 1?
Where?
3.
What's 2 minus 2?
Oh, that's a good point. Yeah, I am sure it's 3. Now if we do inverse cosine of 3 over root 84, we get an angle. No, nobody's going to
Do that in your head.
Do that in my head. Okay.
But that seems quite small.
Not in radians, isn't it?
No, radians. We can give it in radians or degrees. So we're saying what? We're saying 1.24 radians. Okay.
Everybody else get the same?
What's that?
Have we got an answer in degrees?
No, I got
Anybody?
1.24.
You did?
Is that what you got?
Yeah.
Yeah.
Yay!
It's
I got something right.
70.9 degrees.
70.9 degrees. Okay. Fantastic. And it would be accepted in radians or degrees.
If you got one of the roots wrong,
Yeah.
but everything else right, how many marks would you do?
Probably just 1.
Yeah?
Actually,
When I take it off,
yeah. Your method is all there, isn't it?
That's true.
Okay. The last question was, now this was, I thought this was interesting to throw this in, a long division question. It's quite a long time, it feels, since we did any long division. That is divided by there, and we get a quotient. And remember, find the values of the constants A, B, and C. Okay? A couple of ways we can think about doing this, aren't there? What would work? Just actually doing the long division? That's probably the way to go, isn't it? So if we do x squared plus 2x minus 1 into x to the 4 minus 2x cubed minus 7x squared plus 7x plus a. Remember that we need to make sure that our columns are all correct, and we've got 4, 3, 2, 1, 0 we have. We've not got anything missing. What do we times x squared by to get x to the 4? The answer is x squared. So we do that, multiply x to the 4 plus 2x cubed minus x squared. Then we subtract minus 2, take away another 2 is minus 4x cubed. Minus 7 minus 1 gives us minus 6x squared. Bring down the 7x. What do we multiply x squared by? To get minus 4x cubed. Must be minus 4x. Oh, the seagulls there again. So there's our b.
We're not letting see.
We're not letting seagulls. Multiplied by the minus 4x, we get minus 4x cubed minus 8x plus 4x, and we subtract. It's so easy to make a mistake on this, isn't it, with the signs in there and missing the plus 4x and that kind of thing. Minus 6 minus 8 is 2. Or missing that. 7 take away 4 is 3. Plus a. Final bit, what do we times, Dom? What do we times x squared by to get 2x squared? The answer is 2. So that is our final thing. We've got minus x, and we've got a minus 2, so it's a plus 2. Now if we compare what we were supposed to be looking at, the quotient was x squared plus bx plus 2. So b equals minus 4. So that's the value of b. We were told that the remainder was cx plus 7. So minus x plus a plus 2 is cx plus 7. So c equals minus 1, and a plus 2 equals 7, which gives us a is 5. Quite an interesting question. Not particularly difficult, but loads of space for you to make tiny mistakes that would spoil everything. Oh yes. Oh yeah, and